Atomic model. An atom is a sphere with a tidy, which means small, heavy, and positively charged nucleus, which is made up of protons and neutrons, and it is situated at the center. Also, the negatively charged electrons are circulating around the nucleus. Also, most of the space in the atom is empty. Look at mass of an electron is approximately 1/1800 mass of a proton or mass of a neutron. What is atomic number? Atomic number A is the number of protons inside the nucleus. What is mass number? Mass number Z is the sum of the numbers of protons and neutrons. Both protons and neutrons are called nucleons. Therefore, mass number Z is also called nucleon number. Z minus A, that is the mass number minus the atomic numbers, is equal to the number of neutrons in the nucleus. The symbol of an element X is represented by X. A is the mass number, Z is the atomic number. Example 1. The atomic numbers Z of hydrogen is 1, of carbon is 6, of radium is 88, and that of uranium is 92. The mass number A of hydrogen is 1, carbon is 12, radium is 228, and that of uranium is 238. Since number of protons is equal to the atomic number, therefore the number of protons of hydrogen is 1, of carbon is 6, of radium 2 is 88, and that of uranium is 92. Number of neutrons is equal to the difference between mass number and atomic number. Therefore, number of neutrons of hydrogen is 0, and that of carbon is 6, and that of radium is 140, and that of uranium is 146. What are isotopes? 同位素。Isotopes are atoms of an element having the same number of protons but different numbers of neutrons. Examples of isotopes are, for hydrogens, there are 3 isotopes: 11, 2,1, and 3,1. For carbon, there are also 3 isotopes, which is 12,6, 13,6, and 14,6. These are called isotopes because they have the same number of protons but different number of neutrons. For carbon, these 3 isotopes having the same number of protons, also different number of neutrons. Example 2. For the elements D, E, and F, only element D and element F have the same atomic number and different neutron number. For D, number of neutrons is 142. For element F, the neutron number is 138. Hence, elements D and F are isotopes. What is radioactive decay or radioactive disintegration? 放射性衰變。Nuclei can be classified into 2 types, which are stable nuclei 穩定原子核 and unstable nuclei 不穩定原子核。All unstable nuclei tends to become more stable by emitting both radiations and energy through the decay process. The equation for a decay process is that an unstable nucleus X decays to form a nucleus Y and emitting nuclear radiation. Usually, the word energy is omitted. During a radioactive decay process, the elements or the nucleus that decays is called parent nucleus. And the nucleus after decaying formed is called a daughter nucleus. There are 3 kinds of radioactive decay. The first one is alpha decay. In an alpha decay, an unstable nucleus X emits an alpha particles, which is a helium nucleus consisting of 2 protons and 2 neutrons. The equation for alpha decays can be written as X, mass number A, atomic number Z, decay to form a daughter nucleus Y and an alpha particles, mass number 4, atomic number 2. Therefore, the mass number of the daughter nucleus Y will be A minus 4 with atomic number of Y equal to Z minus 2. Note that during an alpha decay, energy is also released, but usually the word energy is not shown in the decay equation. Also, during an alpha decay, the mass number A and the atomic number Z of the nucleus X will decrease by 4 and 2 respectively. Example 3. The decay equation is uranium decayed to form the daughter nucleus Y plus an alpha particles. The second kind of radioactive decay is beta decay. In a beta decay, the nucleus emits a beta particle, which is an electron of speed up to 0.9 times the speed of light. That is, it travels very fast. And beta particles has negligible mass, which is only the mass of an electron. And the mass of electrons is negligible compared to the mass of the nucleus. The symbol for a beta particle is or. The equation for beta decay is the unstable nucleus P decay to produce a nucleus Q with the emission of beta particle. If A and Z are the mass number and atomic number of P, since beta particle, the mass number is 0 and the atomic number is -1. To balance the equation, therefore, the mass number of Q will be equal to A, and the atomic number of Q will be equal to Ez plus 1. Note that during a beta decay, a neutron of the nucleus P changes into a proton and an electron. That is, the neutron changes into a proton plus an electron. Also, energy is released, but that's not shown in the decay equation. And the atomic numbers of the daughter nucleus Q is increased by 1, and the mass number of Q remains unchanged compared with that of P. Example 4. The decay equations is let Pb decays to form a daughter nucleus Y with the emission of beta particle. Mass number of lead 214. Atomic number of lead is 82. Mass number of beta is 0. And atomic number of beta is -1. Balancing the equations, we see the mass number of Y is 214 minus 0, which is 214. Atomic number of Y is 82 minus -1, which is 83. The last kind of radioactive decay is called gamma decay. In a gamma decay, an unstable nucleus, for example, R, changes to a more stable nucleus S of the same element by emitting gamma waves, which is in the form of electromagnetic wave. The symbol of gamma waves is gamma. Since mass number and atomic numbers are both 0, therefore we don't need to write it down. For a gamma decay, both the mass number and atomic number of the daughter nucleus and the parent nucleus remain the same, with only the difference is that the nucleus R is at a higher energy level state. During a gamma decay, energy is also released, and both the atomic number and the mass number remains the same. Example 5. For the gamma decay of cobalt 60 is that cobalt 6027 decay to produce a daughter nucleus is also called cobalt with the same mass number and atomic number. The only difference is that the parent nucleus has a higher energy than that of the daughter nucleus. What is a decay series? If the daughter nucleus formed during a radioactive decay is also unstable, then the decay process will be continued until a stable nucleus is formed. The series of decay process is called a decay series. Note that in a decay series, both the mass number and the atomic number of the parent nucleus and its products are conserved. Example 6. Uranium-238 atomic number 92 undergoes a series of decay to form radium-226 with atomic number 88. Find the number of alpha particles and beta particles emitted during this series from the decay series equation. Let the total number of alpha particles emitted is m, and the total number of beta particles emitted is n. By conservation of mass number and atomic number, we have 238 equal to 226 plus 4m plus 0, implied m equal to 3. Also, 92 equal to 88 plus 2m minus n. Since m equal to 3, therefore we have n equal to 2. Therefore, there are 3 alpha particles and 2 beta particles emitted. Decay series can be represented in a graph. The first kind of graph is mass number A against atomic number Z. When nucleus P decays into Q with the emission of alpha particles, the mass number decreased by 4 and the atomic number decreased by 2. When the nucleus Q decays to produce nucleus R with a beta decay, the mass number remains unchanged, but the atomic number will be increased by 1. Another kind of decay series graph is number of neutrons against number of protons. For a nucleus D decays to form nucleus E with the emission of an alpha particles, the number of neutrons will be decreased by 2, and the number of protons will also be decreased by 2. When nucleus E further decays to produce a beta particle to form another nucleus F, the number of neutrons will be further decreased by 1, and the number of protons will be increased by 1. Example 7. Explain why gamma decay cannot be represented by graph. The reason is that both the mass number and the atomic number of gamma rays is equal to 0. Therefore, gamma decay cannot be shown by the graph.